Maximum minimum problem. Let's solve question number 3. The volume of a container is given by V equal R square plus 1 R minus 2, where R is the radius of the container. Find the value of R so that the volume of the container is a minimum. So, from the formula, we can differentiate. Either we use product rule or we can expand the formula first. Okay, we can see that the formula volume is in terms of R. So when we differentiate, we will get dV over dr. Equal to 0, and we can factorize the equation. So we get R equal 1 over 3 and R equal 1. The values of R that we get here is the critical values. We know that critical values can be either maximum or minimum. To prove that, we must proceed to second derivative. Differentiate d squared v over dr square equal, differentiate 3r square 6r minus 4. Okay, after second derivative, we get 6r minus 4. We know that we use second derivative test to determine concavity. If we get a positive value, then concave upward. Concave upward will give us minimum. If we get a negative value from second derivative, we have concave upward. And concave upward will give us a maximum value. So from the second derivative, we can substitute R equal 1 over 3 and R equal 1. When R equal 1, we get 6 minus 4. Positive. When positive, it is minimum. When R equal 1 over 3, we get negative 2 as the answer. Negative, so it is maximum. So the question asks us to give the radius that the volume of the container is minimum. So our final answer is radius equal to 1 to get a minimum. Maximum minimum problem. Let's solve question number 5. The volume of a container is given by V equal 1 over 3 pi 36x squared minus x cubed, where the height of the liquid in the container is x cm. A, we want to determine the value of x so that the volume of the container is maximum. Hence, find the maximum volume of the container. Here we have the formula volume of the container. Now we want to find the value of x so that the volume of the container is maximum. So first step, we must differentiate the formula. This formula is V in terms of x. So we get dv over dx. 1 over 3 pi is coefficient, so it will stay the same. Differentiate 36x squared, 72x. Differentiate x cubed, 3x squared. Simplify. We get x equals 0 and x equals 24. What we get here is the critical values. Critical values can be either maximum or minimum. From the question, we want to find values of x so that the volume of the container is maximum. To prove that, we must proceed to second derivative. Differentiate 72x, 72. Differentiate 3x squared, 6x. Let's substitute x. What we get is negative 24 pi. A negative value will give us a maximum. And then we want to find the maximum volume of the container. So by using the maximum values of x, we get the maximum volume. Maximum minimum problem. Let's solve question number 2. A rectangle water tank with a closed top is to be made to fill 9 meter cube of water. The length of the water tank is twice its width. A, we want to show that the total surface area of the water tank is given by this formula. And then we want to find the dimension of the water tank. Dimension means that the length, okay, x to x and y. So that the surface area of the tank is minimum. Okay, the first information that we have is volume 9 meter cube. Volume of this water tank is the width multiplied by length multiplied by height. So x multiplied by 2x multiplied by y, we get 2 x square y equal 9. Question A. We want to show that the total surface area of the water tank is given by this formula. If you look closely, the formula is only in terms of x. Okay, surface area. This water tank have 6 surface area. Upper, bahagian atas, bawah, kanan, kiri, depan dan belakang. Okay, let's do the top. The top part is 2x multiplied by x. We get 2x square. Plus, the bottom part is the same, 2x multiplied by x, 2x square. Plus, the front and the back. Front, x multiplied by y. Back also the same, x multiplied by y. Plus, right and left. Right, 2x multiplied by y. Left also 2x multiplied by y. So, these are the total surface area. Total surface area. Because the formula given here is only in terms of x, we want to substitute all y in terms of x. But first, let's simplify the equation. So, from the first information, we get y equal 9 over 2x square. Substitute. So, we get the same answer. Surface area equal 4x square plus 27 over x. Now we want to find the dimension so that the surface area of the tank is minimum. So we want to find x to x and y. Differentiate the function. The formula surface area is in terms of x. So differentiate, we get ds over dx. Differentiate for x square, 8x. Differentiate 27 over x minus 27 over x square equal to 0. To find values of x. So after some calculation, we get x equal 3 over 2. When x equal 3 over 2, y equal 2. So the width is x. So 3/2 meter. Length is 2x. So 3 meter. And height is y. So 2 meter. But we cannot stop here because the question asks for a minimum. To prove that the values that we get will give a minimum surface area, we must proceed to the second derivative. Why second derivative? If you still remember, in topic graph of polynomial function, we learned that to test for concavity, we use second derivative. If we get positive value, then concave upward. Concave upward will give us minimum value. If we get negative for second derivative, it will give us concave downward. Concave downward will give us a maximum value. So to prove, we must proceed with second derivative. Differentiate 8x, we get 8. Differentiate negative 27 over x square. (54 over x cubed). We can substitute x. Which will give us a positive value. We do not need to know the final answer. We just need to know the sign of the answer, whether it is positive or negative. Since second derivative will give us a positive value, meaning that what we get here is minimum. Maximum minimum problem. Let's solve question number 1. A wire of 100 cm is bent to form a rectangle and triangle as shown in figure below. A. We want to find y in terms of x. B. We want to show that the total area is given by this formula. C. We want to determine the values of x and y so that the total area is maximum. And D. We want to find the maximum area. So to find y in terms of x, we can use the first information given to us, which is the length of the wire is 100 cm. Length of wire 100 cm equal 5x plus 3x plus x plus x. 10x plus y 2y. So 2y equal 100 minus 10x. Y equal 50 minus 5x, or we can simplify into y equal 5 10 minus x. B. We want to show that the total area is given by this formula. So total area is area of the triangle plus area of rectangle. Area of triangle 1/2 multiplied by 3x multiplied by y. area of rectangle x multiplied by y. From the question, we can see that the formula for area is only in terms of x. So we must substitute y by 50 minus 5x. Let's expand and simplify. After some expansion and simplification, we can prove that area equal 1 to 5x minus 25 over 2x squared, which is the same as in the question. Proceed to C. We want to determine the values of x and y so that the total area A is maximum. So to get maximum or minimum value, first we must differentiate the function. So here we have formula area in terms of x. So when we differentiate, we can get dA over dx, which means differentiate A in terms of x. Differentiate 1 to 5x, we get 1 to 5. Differentiate negative 25 over 2x squared, we get negative 25x equal to 0, and we get x equal 5. When x equal to 5, from the first equation, y equal 50 minus 5x, we get y equal 25. The values of x that we get here is the critical value. Critical value can be either maximum or minimum. To prove it, we must proceed to second derivative. So d squared A over dx squared equal, differentiate 1 to 5, we get 0. Differentiate negative 25x, we get negative 25. The negative value of second derivative will give us concave downwards, and we get a maximum point. So maximum. Finally, we want to find the maximum area. We can use whichever formula, either the first formula with x and y, or the last one with only x variable. It's totally up to you, because either way you will still get the same answer. The maximum area is 312.5 cm square.